node and the second 10 went to the second node. Okay, the sorting might not happen properly. And also the same with the remove duplicate case also. Okay, if the both 10s went to the different nodes, what will happen? Okay, in the first node, you cannot see any duplicate, and in the second node also you cannot see any duplicate, and both 10s will go to the output. Okay, here my assumption is first 10 is going to the first node and second 10 is going to the second node. Okay, the remove duplicate operation will perform on each node. Okay, in each node we have a unique record of 10, and this remove duplicate stage assume that there are no duplicates, and both the 10 records will go to the output. Okay, that is also mall operation. Okay, to avoid such kind of issues. Okay, for all these stages, join, merge, aggregated, sort, and remove duplicates, we will use hash partitioning technique. Sorry, I skipped in the middle. Okay, in the same partition technique, okay, I have saying like we are using join stage at the first, and then we have using sort, and then we are using, let's say, remove duplicate stage. Okay, in the job. Okay, in the join stage, suppose if we do partitioning on hash partition technique. Okay, what I told you on the sort also we have to use hash, and in the remove duplicate stage also we have to use hash partitioning technique. Okay. Suppose if we again define hash here, again define hash here. Okay, the data again uh, will calculate hash keys based on the internal hash algorithm, and partitioning again, repartitioning happen here, and again repartitioning happen here. Okay, here our requirement is hash partitioning across all the three stages in the job. Okay, instead of that, if we use same partitioning technique, whatever be the partitioning happened here at the first stage, the same partition will be carried forward across the remaining stages. Okay, that is the benefit of a same partitioning technique. Okay, in order to reduce the load or time, okay, to which can happen while doing the repartitioning technique, sorry, repartitioning of the data. Next one is modulus partitioning technique. Just a moment. Sorry. Okay, the next one is modulus partitioning technique. This modulus partitioning technique is also a key partitioning technique. Okay, and it usually the modulus partitioning technique will be applied on only numeric column. So let's say we have some data like all the numeric values. Okay, let's assume I have used two node configuration. Okay, what will happen here is, okay, the key column value modulo division 2. Okay, for all the values it will do, I'm using a two node configuration, it will do modulo division 2 here. Okay, if the modulo division of that value is 0, it will go here. If it is 1, it goes here, like that. Okay, based on the result of the modulus, it will be distributed. Okay, but the disadvantage of this one modulus partition technique is the equal distribution of data is not guaranteed. Suppose uh, here for all these values, if you are getting the modulo division value as 1, okay, these all values will go to the node 1, and node 2 won't have any data to work on. Okay, so the here the problem is in this example, if all the 100% of data is load is went to the node 1. Okay, the equal distribution of data would happen or not guaranteed here in the modulus partitioning technique. Sorry, I missed one here. Okay, and we have a partitioning technique called range partitioning technique. Okay, based on the range of values, the data will be distributed. Okay, usually in one of my earlier project, we do it in the lookup stage. Let's say a certain amount of data only will be uh, considered. Sorry, based on the date ranges or the number ranges. Okay, in such kind of cases, we can use this range partitioning technique. Okay, whereas coming to the auto, okay, if we put the partitioning technique as auto, the data stage itself can decide what partitioning technique it has to apply on that stage. Okay, mostly the auto partitioning technique will work fine without any issue. Okay, here there is no the data stage itself will decide. Okay, it can take any partition technique based on the type of stage we use. And the last one is DB2 partition technique. It will be considered only if you use DB2 database as a source. Okay, if you use DB2 database as a source, then the data will be distributed, okay, like it do in the DB2 database. Okay, DB2 database is the one which owned by IBM. Okay, so they might have created one partitioning technique for themselves. Okay, here the questions we get in interview is like, okay, what are the different kinds of partition techniques that they will ask? Okay, what is the advantage of entire partition technique or where it is used? Okay, entire partition technique is used in lookup, and the most popular one is hash partition technique, and it is used for various stages like join, merge, aggregator, sort, and remove duplicate stages. And in entire partition technique, what will happen? The entire data will be distributed across each node. If we have 100 records, the 100 records will go to the node 1, node 2, and node 3. All the nodes will carry this entire data. Okay, in the hash partition technique, we have to decide one key column, and data stage will create some hash value internally based on the column value. The same records will go to the same nodes. Like that, if we have different department data, okay, based on the hash value, same departments will go to the same node. And in the round robin, it's an equal distribution, like the first record will go to the first node, second record will go to the second node, like that. Okay, the advantage of this round robin partitioning technique is the data will be equally distributed across all nodes. Okay, next, random. Random means the data will be distributed randomly. Okay, there is no particular criteria for this, but mostly it will, this one also guarantees equal distribution of data across all nodes. Same partition technique is like, suppose if we define one, this is the example, if we define one key partition technique for the first stage, and if we require the same partitioning technique on the remaining stages as well, no need to define it, this one exclusively. Suppose if we define hash here, okay, the data will be repartitioned again here for the sort stage, and it will be extra burden for the stage or the job. Okay, to avoid that one, if we use same, whatever way the distribution happened here, and it will move in the same manner for the remaining stages. There is no read partitioning or redistribution will occur here if we use same partitioning technique. Okay, modulus is also a key partition technique. Here we have to define one key column, and based on the number of nodes, okay, the modulo division will happen on the key column. Okay, here one more thing, the key column must be a numeric key column, then only the modulo division will happen, and based on the modulus value, okay, usually in the data stage we will consider like node 0, node 1, node 2, like that. Okay, the first node is node 0, and then node 1 and node 2. Okay, based on the modulo division value, the records will be distributed across different nodes. And this is here also we require one key column. And in the range partitioning, based on the range of values, the data will be distributed. If we set certain range of data should go to some node, okay, like that, the data can be distributed here in the range. And this range is also a key column, sorry, key partitioning technique. Okay, we must define a key column, and for on that we can divide the data based on the ranges we have provided. There is a concept called range map. Okay, by using that one, we can divide the data. And the other one is called auto partition technique. Here, we don't define anything. All these concepts will not be useful here. Okay, the data stage itself decide which partitioning to use. Mostly it will work correctly. Okay, sometimes if it is getting any issues, then we have to go for dedicated partitioning techniques for those stages. Okay, DB2 partitioning means, okay, it will use the same partitioning like it will do in the DB2 database. Okay, that is exclusively if you use DB2 database as a source. Okay, here the questions is based mainly for entire and hash, where we use entire partitioning technique, where you use hash partitioning techniques. And the other question is, what are the key partitioning techniques in data stage? Okay, the first, for which partitioning technique you need a key for hash, I told you we need a key column. Okay, for that key column, it will take some hash value will be generated, and same type of records will go to the same node. Okay, this is the first one. And next, where we are using the key column for the modulus, we are doing key column. Okay, on the key column, we are doing the modular division, and then we are distributing the data modulus. And the third one is range partition technique. Here also we need a key column, and based on that key column, the data will be distributed. Okay, these are the three key partitioning techniques. But this is about parallelisms. In the parallelism, we have two types. One is pipeline parallelism, and the other one is partition parallelism. Pipeline parallelism means all the stages will work uniformly. Okay, let's say there are billion records. The second stage won't wait for the first stage to process all the billion records. Whenever the first record got processed, immediately it will be picked up by the second stage. And if the second stage completed the processing of the first record, then it will move to the stage 3. Okay, all the stages will work parallelly. Okay, whereas coming to the partition parallelism, okay, in each stage we can create multiple nodes, so that the performance will be improved by distributing the data across different nodes. And the way of distributing the data is by using the partitioning techniques. Okay, the entire hash, round robin, random, same, modulus, range, auto, and DB2. These are the different partition techniques. I hope you guys got it. Jansi, you can show in any of the job how to select this. Thank you. Hello, Jansi.
Hello. I could not able to unmute myself.
Yeah, now you're audible.
Yeah.
Oh, okay. I make you as a host. Try now.
Yeah. I'm sharing my screen. So, as Sunil discussed about partitioning techniques, we can see those partitioning techniques in all the processing stages that we are going to use. Where we can see them are here. On input and output tabs, we can define them. So here if you see partitioning and collection. So by default, it is going to make use of auto partitioning so that data stage will take care the partitioning of the data to have optimal data distribution. But say suppose I know how to make use of partitioning techniques and I know how to increase the performance of my job. Then we are going to explicitly make use of the partitioning techniques which are available over here. So here it is a filter stage, right? So we can make use of hash partitioning. Whenever we do define a hash partitioning, as it is being told, it is a key partitioning technique. We need to define the key column. Say suppose I would like to apply the partition on department ID. Then what it is going to do is it make use first it will see the distinct department IDs and the number of nodes it is using. Say suppose we do have total of 5 departments and 3 nodes. Then these 5 departments are going to be distributed among these three, department one category will go to node 1 and 2 category will go to node 2 likewise. Each of the partitioned department will execute on a specific node. If it runs like that, what happens is the performance of the job is going to be high. How it is high is when the data is arranged in an order. Obviously, the operation is going to be easy. Whatever the sort of transformations we are going to apply on our data, if it is in an arranged way, we can easily look up to the data, right? Say, suppose either in join or merge or whatever may be the transformation. When we are doing a joining operation, what it is trying to do, it is trying to match the columns between the two sources, right? While it is doing that match, if the data is in a sorted way or in an order, then it can easily implement that task, right? So those things can be achieved with the help of these partitioning techniques. And hope you all understand. And this is the place where we need to define these things. Even though we consider these partitioning techniques, now we could not able to see the performance because we are considering only very small amount of data, like 5 records or 8 records, something like that. We can explicitly see the difference in the real-time projects because that is going to deal with millions of records, right? Say suppose if we use the partitioning technique, it is going to be executed around uh, say suppose 1 minute. When we do not use the partitioning techniques, then obviously it will take 3 to 4 minutes. That's the uh, way of performance we can see with and without using the partitioning techniques. Okay. Uh, while we are using some complex jobs, we will try to make use of those partitioning techniques as well. And in the next class, I'll also show you the configuration file where we can see the node configuration enabled for a particular project. That is also should be known so that we'll get an idea how the data is distributed or how node configuration can be defined. Okay. So we will see tomorrow with another processing stage. Thank you, Sunil. Thanks, everyone. Any questions? Anybody? So I'm assuming all are good. Bye.